also. So see, first I'll just walk you through. This is the first chapter. Okay, these are all units and everything. Okay, which is I think you'll be able to go through on your own. So we'll skip this chapter, but I'll just So these are the notes. Okay.
Okay.
So what is the scientific method and all that, right? And just go through it, just read it. Okay, if you don't understand something from it, you can ask me. This is the scientific method. Okay, first there are observations, then there's a hypothesis, then we perform experiments to test the hypothesis. On the basis of hypothesis we can make a theory also, and so on and so forth. Okay, so this is the first chapter, and in this basically there are units and things like that. Okay, these are experimentation and measurement, and these are the 7 fundamental SI units of measure. Just maybe like mass, length, temperature, amount of substance is measured in mole, time is in second, electric current, ampere, and luminous intensity is a candela.
Yes, sir.
Okay. Again, Ritika, these things are again, tera is 1 tera is 10 to power 12. So teragram means 10 to power 12 grams. 1 giga is 10 to power 9. Mega is 10 to power 6. And you can see all these symbols here. Clear?
Yeah.
Okay. These things, if you, I mean, this is just information. Okay. So you can just go through them and you can see. Deci, centi, milli, pico, femto, right? Again, then they have discussed all this mass measurement. Okay. How do we measure? How do we define length? Okay. What is the definition of the meter and so on and so forth. Then there's the temperature. They have all the scales we have. Okay. And yeah, this is how you convert temperature from one scale to another. Okay. So this is something which we study in class 9 and class 10. And these are derived units like area, volume, density, speed, acceleration, right? We combine 2 or more units. And this is again density, mass by volume, right? All these things are clear, right? You know them, right?
Yeah.
Okay. Right. I'm just, if you don't know, you can tell me. Okay. Right?
Yeah, sure, sir.
Yeah. And anything you don't understand, because this is 1-to-1 and we are just trying to catch you up so that you can join the regular thing. So even if I say that you must be knowing this, and if you don't know, you just tell me, no, sir, I don't know. Okay.
Okay.
Yeah. So the kinetic energy, derived units, and all this measurement. And there, I think, and they have talked about significant figures also.
Yes, sir. Sir, I'll just tell you what I do not understand till now, right?
Yeah. You can tell me.
So in the first chapter, which is some basic concepts of chemistry.
Yeah. Don't worry, Ritika. I'm going to start anyways from the beginning. Okay.
Okay.
Right.
Okay. Yeah. So,
Yeah. Because see, even if you have studied and even if you would have told me that you would have understood, I still would have started from the same thing because you will understand after today's lecture. Okay, you go through these significant figures and everything on your own. I'm just running through. Okay, this is our template, and then I'll start immediately with the lecture, because I don't think so. I interview teachers also. Okay, even teachers have not understood the mole concept. Okay, the counting, how do we count, right? They are so uncomfortable suddenly, right? And
yes, sir.
when I teach the 12 pass students, even after attending 2 or 3 years at Allen, they also do not know. They have not understood. So what we are going to understand now, you're going to, okay, so you can go through that chapter. Okay, now I'm going to start with this. Okay, see, so I will just start with the counting first. Okay. So yeah, so let us yeah, okay, I'll start with the, see, this is our basic counting principle is this. First, I'll start with this. We know that 1 dozen is 12 things. Okay. You also know this 1 century. Right? So, similarly, I have in chemistry something called this. And this is equal to, this is a very big number. Okay?
Yes, sir.
1 dozen is 12, 1 century is 100, 1 mole is. See, now if I ask you 24 eggs is equal to dash, right? So immediately we'll be able to answer it, right? We'll do like this: 24 by 12, right?
Yeah.
Right?
Yeah.
This we have done. So if I ask you that Kohli made 300 runs, so we are immediately able to do this, huh?
Yeah.
Okay. Now, actually, what is going on here? Huh? So what is going on is this: I have 1 dozen equal to 12. So how can I make one? Just see how we will make one out of this. I can write this as 1 dozen by 12 is equal to 1, right?
Yes, sir.
This is one conversion factor. Other thing what I can write is we can put 12 here and 1 dozen here, right?
Yeah.
And this also becomes 1. See? And these are what we are going to call conversion factors.
Okay.
Conversion factor, and these conversion factors will exist for everything wherever we have two things which are equal to each other. So conversion factors means we have divided them and we have made one out of it. Okay.
Okay.
So now we come back to that. Okay. Now when we say 24 eggs, okay, so is equal to dash dozen, huh? So suddenly we start dividing all that. Actually what is happening is this: 24 eggs, and the only thing which I can do is I can multiply this thing by 1, right?
Yeah.
So I have two conversion factors. One is this and other is this, huh? Okay. But I want dozen on the numerator. I am converting into in the dozen. So when I multiply it by 1, which one I will multiply it by? I will multiply this thing by the top one. I will multiply this by 1. And this 1, I'll write like this. See, eggs into 1 is, I'm using this one, this fancy one. Huh? Got it?
Okay.
See? So that is how I get 2 dozen eggs. Okay?
Okay.
And if I say 3 dozen eggs equal to dash, so now I want to convert dozens. So I have to use this one. So I multiply 3 dozen eggs, 3 dozen into 1. And which one I am going to take? I am going to take the 3 dozen into 1. And which one I'm going to take? I'm going to take this one. 12 divided by 1 dozen. See? Why this one? Because I'm cancelling the ones. Huh? See? I'm cancelling the dozens. Huh? And now this becomes 36x. Huh? Yeah? You can hear me? Can you hear me?
Hello.
Yeah. Now you can hear me? I cannot hear you. Let me know when you can hear me, or just speak up.
Yeah, I can hear you now.
Okay, now so 3 dozen means how many eggs? So which one I have used out of these two conversion where the dozen is appearing in the denominator, right? Ritika, I think you can disconnect and connect again. You can disconnect and connect again. Huh? Yeah, disconnect and connect again. I'm here only. Yeah. Hi. Ritika? Some problem in there. Download the app. Huh?
So can you hear me now?
Yeah, I can hear you now.
Okay.
Okay, you download the app on also, okay?
So which app?
The Zoom app.
Yeah, I have the app.
Okay. You are in your laptop. You have the app. Huh?
Yeah.
Okay. Cool. Okay. So why is it going like that?
So what is going on there?
I mean, why you are not able to hear me and everything?
Oh, sir, my network. I'll like right now I'm sitting in my room. From tomorrow I'll sit in the other room. It's better there.
Okay. Great. So, okay, I'll because I have the class after it. Anyways, we will continue. So now here, see what we have done. I multiplied this by 12, this thing by, right? If I have to convert 3 dozen into a number, which conversion factor I'm using? I'm using where the dozen is in the denominator, right?
Yeah.
Because I want the dozen to cancel out, right?
Yeah.
So from everywhere, I'm going to get 2 conversion factor. Conversion factor means 1. Okay, how whenever I'm equating two things, for example, for the dozen, we already know if I want the conversion factor for century, the conversion factor for century will be either 1 century by 100. This I will use, or the other thing is 100 by 1 century, right?
Yeah.
These are the two ones I can create here. So
Yes.
similarly with more. Now, this is our counting principle. See, our counting principle is this, that whatever we can say about a relative number of atoms in one molecule, we can say the same thing about relative number of moles, about relative number
Yes, sir.
of moles. This is the counting principle on which we are going to build things. Okay. So first, I'm going to ask you a very simple question. So it's like the question is this, and we go to Mars, and there people have 7 eyes. Huh? Okay. So how many dozen of eyes 13 dozen Martian have? Got it?
Yeah, before that, the thing you've given, right? Relative number of atoms in one molecule.
Yeah.
How can you say the same thing about relative number of moles? Like, can you just?
Yeah. I'm just coming to this. That is why I gave you this question.
All right.
Yeah. You will see. Yeah. Okay. The main thing is you're going to see things. Huh? Not remember or something like that. Right? You're going to see things. Okay.
Yeah.
Don't worry.
Yes, sir.
That is all my responsibility. Yeah. Go ahead.
Yeah, and I just wanted to let you know, I have my first unit tests on for chemistry. It is on 2nd July.
Don't worry. I will manage. Huh? Just focus. Don't worry. Huh? Okay. Just focus on the process. All those are my headaches. Huh?
Okay, yeah. Yes, sir.
Your headache is only what I'm telling you to do. Okay.
Yes, sir.
Okay.
One second, sir. I'm doing it.
Yeah.
So the number of Martians or the number of people, is 156.
Yeah.
So then the number of eyes would be 156 into 7. So 1092 eyes.
Yes. Very nice. You can use calculators. Huh? In my class, I allow people to use calculators.
Oh, in our either way we can't use it in school. So
Yeah, I know. You cannot use there, but because we do things fast here, huh? You can always calculate. Okay.
No, for now I think I got it. 91 dozen eyes.
Yeah. Okay.
Yeah.
See. Okay. Now I'll just show you. Okay. So now what about that relative number things, and see how we are counting. Huh? Suppose one person on earth we are talking. Huh? 2 eyes. Huh?
Yeah.
2 person. 2 into 2 eyes. Huh?
Yeah.
3 persons. 3 into 2 eyes. Huh?
Yeah.
And like this, I count and I reach 12. 12 person. 12 into 2 eyes. Huh?
Yeah.
If I write in dozen, I will say 1 dozen has 2 dozen eyes. Huh?
Yeah.
So whatever I was able to say about one person, I can also say the same thing about the relative number of dozen,
Yeah. Yeah.
right?
Yes, sir.
So if I go on and I reach this 6.022 into 10 to the power 23, then it will be 6.022 into 10 to the power 23 into 2 eyes, right?
Yeah.
So 1 mole has 2 mole eyes. Huh?
Yes, sir.
See, so whatever I am able to say, now here we assume that person is the molecule, huh? And eyes are the atoms. Huh?
Yeah.
So whatever I am able to say about one person and his eyes, I can also say the same thing about the relative number of the dozens or the moles. Huh? So if I'm saying that one person has 2 eyes, I can also say that 1 dozen people will have 2 dozen eyes.
Okay. Yeah.
Yeah,
Yes, sir.
right. And I can also say the same thing regarding 1 mole eyes. Huh?
Yeah.
I can also say that same thing about 1 century. 1 century person have 2 century, right?
Okay. Yeah.
Right.
Yes, sir.
So now coming back to this Martian question, if one Martian has 7 eyes, so 13 dozen Martian will have 13 into 7 dozen, 91 dozen directly.
Yeah.
See?
Oh, okay. I just simply.
Yeah. Now you see, because now we multiplied by 12 and then finally we divided by 12. So that division and multiplication is redundant, right?
Yeah.
Okay, you got it now?
Yes, sir. Yes, sir.
See, we are able to say about the same thing. Okay, now I'll just come back to this and okay, we'll do more questions. Huh? So I'll say that how many mole of O atoms are in 0.8 mole NaHCO3. Okay.
Okay.
Okay. Now I'll do it. So I don't know anything. Okay. And I don't want to know anything. All I know is that one NaHCO3 has 3 oxygen atoms. Right?
Yeah.
So whatever I can say about one, this I can also say about the relative number of moles.
Okay. Yes.
Right?
Yes, sir.
So it means 1 mole NaHCO3 has 3 mole O atoms. Yes?
Okay. Yeah.
So 0.8 mole NaHCO3 will have 0.8 into 3, right?
Yeah.
Got it?
Yes, sir.
Because if 1 mole has 3 mole, then 0.8 has how much? Unitary method, huh?
Yeah, that I got, but
Yeah. Ask.
so we can directly assume that 1 mole of NaHCO3 has 3 moles of oxygen atoms.
No, see, I don't want to jump there. I want to begin with one single molecule, which I am able to see, feel, and right.
Yeah.
And from here, I can jump, huh?
Okay.
Right? Because whatever I can say about this one NaHCO3, I can also say about the dozen or the moles.
Okay.
We just learned this, right?
No, I just don't get how you can say that it is the same as 1 mole of NaHCO3 and 3 mole of oxygen.
You can say, I mean, you are asking or you're telling me?
No, I'm asking.
You are asking how we are able to say this, huh?
Yeah.
See, the same thing. Because one NaHCO3 Because this is just right now what we learned, that if one person has two eyes, then 12% or 1 dozen will have 2 dozen eyes, right? Because one person had two eyes, I can multiply, I can simply, that will step up with the same thing, right?
Yeah.
So, and I can go on till mole. So mole also will be the same, right? Instead
Yeah.
of dozen, we have written mole. Huh?
Okay.
Got it? Or we can start with one HCO3 has 3 O atoms, and so 2 NHCO3 will have 2 into 3 O atoms.
Yeah.
And I'll go till 100 into 3 O atoms.
Yeah.
And I go till 6.022 into 10 to power 23.
Okay.
We'll have this. Huh?
Yes. Yes, sir.
And now this we call fancy is 1 molar.
Yeah.
So this is 3 molar.
Yeah.
See?
Okay.
Right?
Yeah.
Got it?
Yeah.
See, this is the essence of calculation. It's okay. It's okay. You can take your time. Huh? Okay. You can
Yes.
take your time and you can understand this, like, I mean, the way you are trying to understand things. Okay.
Yes, sir.
Because this is a very powerful concept. Huh? See what is happening. This is from a book which is called Bruce H. See, because we don't teach students that this is what we are doing, right?
Yeah. Yeah.
See how it is growing, and ultimately will end up with the same thing. So because we are multiplying it by this one thing, we are multiplying by both side by 6.022 into 10 to power 23. So it is becoming Avogadro's number.
Okay.
Huh? You can also think it like that. If I multiply it by Na, then it will become 1 Na, and Na is Avogadro's number. So this much NaHCO3 will have 3 into NaO atoms. Huh?
Okay.
Multiplying both side by Na. Huh?
Okay.
That also you can see, or you can also see like this. Huh? Yeah.
Okay. Yes, sir.
You got it?
Yeah.
Okay. So, Ritika, the main thing is that whatever we can say about one single molecule and their relative number of atoms, I can immediately switch that relationship into the mole. Okay.
Okay.
That is the counting principle. That is how we are going to go. Okay. Clear?
Okay. So if it was like 2 NaHCO3, that would be 2 mole of NaHCO3.
If it is 2 mole NaHCO3, then it will be, we will have 6 mole oxygen atoms, right?
No, sir. Can you repeat?
If you're taking 2 mole NaHCO3, then it will have 6 mole O atoms, right?
Yeah.
Right?
Yeah. Yes, sir.
Got it?
No, but the basic thing is that as it keeps increasing, let's say 5 NaHCO3 or whatever, the number of moles will also keep increasing.
The number of moles will keep on increasing for what?
Like 5 mole of NaHCO3.
If we say 5, see, if we know the relationship between 1 mole and the relative, then I can write the relationship between 5 mole also, right? 5 mole NaHCO3 will have 15 mole O atoms. Huh?
Yeah.
Got it?
Okay.
Right?
Okay, yes, sir. So after that, can you just scroll a little bit up for the question?
Yeah.
Yeah. So they're asking us for 0.8 mole, right? So it
So
does
if 1
not
mole has
matter.
3 mole, then 0.8 will have 0.8 into 3, huh? O
Yeah, so
atoms, mole O atoms.
if it was either 2 NaHCO3 or 5 NaHCO3, will it affect the 0.8? No, right?
No. Don't even think like that. Okay. Just don't think. Don't think. You don't know anything. You are not in a position to think. Huh? Just stay with this, what I'm trying to teach you here.
Okay.
Tell you. Okay.
Okay.
Okay. Don't even think. We I'm trying to teach you how to count the big numbers. Don't worry. In the end,
Okay.
you will be everything, whatever you want to know will be clarified. Huh? Don't worry. Okay.
Okay. Okay.
But don't even think. Don't even try to ask questions. Initially, everyone tell you must ask questions. Don't ask questions. Just focus what I'm trying to tell you. After a while, you will know everything. And after that, if you don't understand, you can always ask me. Got it?
Okay, yes, sir.
Okay, this is how we work. Whatever I'm just do not try to even think or try to ask. Only if you do not understand this specific question, then ask me. Okay, because we are trying to build gradually. Okay.
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 Yes.
Okay. Now you see, now we go to the next question. Yeah, I'll go to this. So next question is, how many mole of Na atoms are in 0.7 mole Na3PO4? Got it?
Okay, yeah.
So
Yeah.
you tell me.
That's 2.1
0.1 what?
mole.
Yes. I'm so happy now. Okay.
Yeah.
See, now you are able to see. Now you are learning something. Huh? And how many? And next question is, how many O atoms above? How many mole of O atoms?
2.8 mole.
That is simply 0.7 into 4.
Yeah.
2.8 mole. Okay. Great, great, great. Okay. Now we'll try to do things. Now we'll change this question a bit. How many O atoms? Now I have not asked the moles. I've asked now I'm not asking how many dozen of eggs. I'm asking initially, suppose I asked you and you said, sir, we have 2 dozen eggs. And I ask you how many eggs. Then you will not say 2 dozen. I'm asking for the number. Okay.
Yeah.
Then you'll say 24 eggs. Okay. So how many O atoms are in 0.8 mole Na2CO3? Okay, I'll do this. So how many? So first we can calculate the moles, because I can 1 Na2CO3 has 3 O atoms.
Yeah, so 2.4 mole.
So for 1 mole, I'm just doing it so that you know,
Okay.
has 3 mole O atoms,
Yeah.
and 0.8 mole will have 0.8 into 3, right?
Yeah.
So this is 2.4 mole. But we have not asked the moles.
Yeah.
2.4 mole means 1 mole is, right?
Okay.
Yeah. See,
Okay, yeah.
yeah. Whenever you are confused, in your head, make this mole as dozen.
All right, yeah.
So 2.4 dozen means 2.4 into 12. Okay, so if it was dozen, we multiply it by 12. Why do we multiply it by 12? Because there are 12 notes in the music? No, we multiply it by 12 because 1 dozen is 12, right?
Yeah.
So if it is 2.4 mole, I will multiply it by 6.022 into 10 to the power 23, right?
Yeah.
So this is 2.4 into 6.022 into 10 to the power 23, and we write it as Na, right? Avogadro's number, right?
Yeah.
Okay. See, now you have gone one step up, huh? Right?
Yes, sir.
Yeah. See? Okay. So I know this because I faced a lot of problems during my IITJ preparation, right? How to count.
Okay.
And in this chapter, it seems as if every problem is getting solved from a new perspective, new concept, right?
Yes, sir.
There is no unified approach. We will have a unified approach. We will solve all these things just by mole, because mole on those 7 quantities, Ritika, the mole was listed. Okay, not
Yes,
the
sir.
grams and something like that. We'll continue with the mole. Just wait until you'll see our approach. Okay. So
Okay.
now we know that 0.8 mole is this much. Okay. Now I'll come to this that okay, I'll use this that moles is equal to given mass grams divided by molar mass, right? This you know, right?
Yes, sir.
Okay. If you don't understand anything, just ask me. Okay. See, this is so now see how we will start modifying things. Here, see how many.
So one question regarding the formula.
Yeah.
So the molar mass can be written in grams, right?
No. It is always gram per mole because it is the mass of 1 mole of a substance.
Okay, so for molar mass, it's always gram per mole. What
Yes,
is
because
okay.
only then the units will gram will cancel and we'll get the dimension as moles, right?
Yeah.
Okay. If it is just in gram, then we'll get a dimensionless quantity. But mole as a unit, the mole is a dimensionless, but yeah, mole we write 1 mole, right?
Yeah.
Okay. So if it is just grams, then everything will, right?
Yes, sir. Yes, sir.
Got it? Okay. So now how many O atoms, and this also I'll do, are in, I'll use 16, whatever, 10.6 gram Na2CO3. Okay, see, this is my question. So see how I'm going to approach this. Huh? First, I know that, see, immediately I have to start thinking in terms of moles. Okay, I have to find how many O atoms are in this one. So my first step is that 1 Na2CO3. This has 3 O atoms. Huh?
Yes, sir.
So 1 mole has 3 mole O atoms. Yes?
Yes, sir.
Okay. But I don't know the moles of Na2CO3. So mole Na2CO3 is equal to given mass of Na2CO3 divided by molar mass of Na2CO3. How we will calculate 2 sodium, 2 into 23 plus 1 carbon, 1 into 12 plus 3 oxygen. Each oxygen has 16, right?
Okay.
Okay.
Okay. So you just learned the values of.
Yeah, it is given also.
Okay.
Okay. The masses are given. Okay.
Are they given in the? They're not given.
Yes. They'll be given. Okay.
Okay. Yeah.
So molar mass of sodium is 23, carbon is 12, and oxygen is 16. Got it?
1 second. Sir. Yeah. Yeah. Got it.
Okay. So this becomes 10.6 gram divided by 106 gram per molar.
Okay. Yes, sir.
So this becomes 0.1 molar.
Yeah.
So now I know 0.1 mole Na2CO3 is there. So it implies 0.1 mole Na2CO3 will have how many? Will have 0.3 mole O atoms, huh?
Yeah. Okay, because 0.1. Okay.
Yeah.
Yeah.
But they have not asked me mole, they have asked me how many. So 0.3 mole O atoms
Into
0.3 dozen means into 12. So 0.3 mole O atoms is equal to 0.3. 1 mole is just 1 Na.
Yes, sir.
Got it?
Yeah. Also, are we allowed to write like 0.3 into Avogadro number, or do we have to write 6.022?
You can do anything. Huh? If they
Okay.
have asked the number, you can just put the number. If they ask you in terms of Na, then you can just write this also.
All right. That's
Okay.
how you write Avogadro number.
Oh, yeah.
Okay.
Okay. They
Yeah.
both are same things. Huh?
Yes, sir.
Got it?
Yeah.
See? Now you have made some progress. Huh? Earlier you could not have solved this one. Huh?
Yeah. Yes, sir.
See? We are just starting with one. Huh?
Okay. Yeah.
And then we see we are developing that mole thing. Huh? We are developing it mole by mole by mole. Okay.
Yes.
Every time, Ritika, we have to think in terms of moles. Okay.
Okay.
Every time we have to think in terms of moles.
Okay.
Okay. If you are thinking something else, it means you are doing it wrong. Okay.
Okay.
So you have to think that 1 is this, so 1 mole is this. Now, this is the first step in counting these simple things. Huh? Because this you can see, and this you have learned. This I told you that whatever you can say about the 1, you can say about the moles also. Huh?
Yeah.
So this is the first step, and this is the second step. And after that, you have to calculate the moles. Huh? Now we'll go to another question. See, okay. So now next question is, how many mole of O atoms are in 16.8 gram NaHCO3? Okay.
Yeah.
Then the next thing is, how many O atoms? See, these are two parts. First, we are
Okay.
asking moles, and then we are asking this. And the molar masses are given like this.
Okay. But I think for my exam, I have to learn this.
You don't have to learn these masses. Huh?
So they don't give it in the exam. I don't think
Don't
so.
worry, don't worry. They will
Okay.
ask. Don't worry. You can ask. Okay. And gradually, I'll tell you how to remember also. Huh?
Okay.
Okay. So
Okay. So
till oxygen, you just double it. Huh?
all right. Okay.
Okay. Except for the hydrogen. For example, helium is atomic number 2, so it will be 4. Okay.
Okay. So
More or less, it is like that. So carbon is 6, so it is 12. Nitrogen is 7, so it is 14. Oxygen is 8, so it is 16. Huh?
Okay.
But it's not always like that, because actually the mass number is equal to protons plus neutrons, and they will vary. But don't worry, huh? You can
So
always
I
ask
just
for
learned.
the atomic masses, huh? From them.
Okay. So
Yeah.
our teacher said we're not allowed to. So I'll just learn all the main ones.
What is the teacher's name?
Padma ma'am.
Tell her that we are not here to remember the molar atomic masses. Huh? Okay. In all the competitive exams are they are given. Huh?
All right.
Okay.
Okay.
In all the competitive exams, the masses are given. Okay.
All right.
Yeah.
I'll
It is just because Padma does not know the chemistry. Okay. That is why she is asking you to cram all these things. Huh?
Okay, sir.
Yeah, yeah, yeah. And please, just like, anyways.
Yeah, I'll just solve it.
Yeah, yeah. Tell her that, ma'am, why they are given in all the competitive exams.
Okay.
Just ask.
So it's 0.2 moles. So
Okay.
that will be zero number of oxygen atoms. So 0.2 into 3, which is 0.6
0.6 what?
mole.
Yes. Always say mole, huh? Okay.
Yeah.
Without units, it's nothing, huh? It's like
Yes.
somebody asks the age, we always tell 18 years, huh? Okay.
Yeah. Okay. And the number of atoms is 0.6 into Avogadro number.
0.6 Na, you say, huh?
Yeah. And
Okay. Yeah. Great. Yeah, yeah. So I'll just write the. So molo is equal to 60. This was how much? 60, 84, 0. Yeah, yeah. 0.2 into 3. 0.6, huh?
yeah.
Yeah.
No, I got 0.2.
No, mole O.
Oh, mole, oh yeah, 0.6.
Right. I'm just directly writing, and O is equal to 0.6 Na, right?
Yeah.
Okay. See? See, now you are able to do things, huh? Okay. Just see. At least you are able to count things, huh?
Yes, sir.
Okay. Okay. Now we will see that how we will approach the equations, huh? Because everything, you see what is happening in the chemistry, we go in the lab and there's a reaction occurring, and after the reaction we are supposed to find out how much we will get, what is the amount we will get, huh? Okay.
Yeah.
Now watch this carefully. This is the most important thing. This is applicable to all the chemistry, huh?
Yes.
Suppose I have a balanced chemical equation. The keyword is balanced. It must be balanced, okay? And suppose I have this balanced chemical equation. And this small a, small b, they are called stoichiometric coefficients, right?
Okay, I do not.
Small a, small b, small c, small d. We call them stoichiometric coefficient. They are the numbers that appear before the equation. Huh?
Okay.
Okay. I'll just show you that what are coefficients. Okay. A and B are reactants. Huh?
All right.
And we call C and D as products. Okay.
Yeah.
Whatever is on the right hand side, they are the products. Left hand side, they are the reactant. And these small a, b, small c, small d, they are the stoichiometric coefficient. For example, if I have this equation, 2H2 plus O2 is equal to 2H2O, it implies the stoichiometric coefficients are 2, 1, and 2. Huh?
Yeah.
Okay, here it is 1. When there's nothing, there's 1. So they are stoichiometric coefficients. Okay. Got it?
Yeah. Okay.
H2 and O2 are reactants.
Okay.
Okay.
Yeah.
And H2O is product. Got it?
Yeah. And it must always be balanced.
Yes. Huh? Okay. The equation must be balanced, huh?
All right.
As what we are doing, huh?
Okay.
Okay. Even if it is not balanced, then Modi ji will come and he will say something else, and other will, Sidramaiah will say something else. Huh? It must be balanced, huh? Okay.
If it's not, also we must balance it, right?
Sorry.
No, if it's not, then we must balance it.
Yes.
Yeah.
Right?
Yeah.
Yeah. Okay. So now we will come back to again the same thing. So I've just given you one example. So if we have Ritika balanced chemical equation AA plus BB, I'm just generalizing this for the first. Then this thing will always be true, that mole of reactant A divided by its stoichiometric coefficient will be equal to mole of reactant B divided by its stoichiometric coefficient. This will be equal to mole of C divided by its stoichiometric coefficient. This will be always equal to mole of D divided by its stoichiometric coefficient. Okay.
Okay.
So, and this is the basis for all our chemical calculation. So whatever in our notes I'm putting in the box, that must be in your heart and mind. Huh? Okay. Okay. So this is the thing. Now we'll take few examples what we mean by this. So for example, I have, let's say, 2NaHCO3 goes to Na2CO3 plus H2O plus CO2. So I can see that this is balanced. Okay, you can also check that it is balanced.
Yeah, it's
And so for this, we can write mole of NaHCO3 divided by 2 will
Okay.
be equal to mole of Na2CO3 divided by
1.
is
Okay.
equal to mole of H2O divided by is
1.
equal to mole of CO2 divided by
1. Okay.
yes, please ask.
No. You can continue, sir. I think we'll come to that either way.
Okay, you got it this
Yeah.
much?
Yeah.
Okay, this is clear, huh?
Yes, sir.
Okay, so this I just this I gave you one example that look what we have to do, and we can immediately write we can immediately write these things, right? Okay.
Yes, sir.
Now if I know the balanced equation, it means I know this number in the denominator,
Yes, sir.
right? And if I know the mole of only one substance, whether it is NaHCO3, whether it is Na2CO3, whether it is H2O, whether it is CO2, just one, then I can
Yeah.
calculate the moles of all the substances.
Yeah.
Right?
Yes, sir.
See, now we are able to see something, huh? Because if we can know the moles, then I can also calculate the mass, huh?
Yeah, okay.
Right? Because we have this formula, right? Where did it go? Where did it go? Here,
Yeah.
right? So
Yeah.
if I know the moles, and obviously the molar mass we'll always know, okay?
Okay.
Okay, so we can just multiply mole and molar mass, and I will get the mass, right?
Okay.
Right?
Yeah.
Okay, we'll come to we'll keep on shuttling for back and forth. So that is the first thing, huh? And yeah, see, before I continue, if you go to this, we have this chapter 2, and there all these elements and all this, what is happening, and these are the normal things, okay? Atomic structure, electrons, and so I you must go through this chapter 1, chapter 2, okay?
Okay. Yeah.
So I'll just show you just one thing, okay? For example, I'll just share you the notebook after the class.
Sure.
Okay, so this is I don't want to here. See, there we are like converting between mass and numbers of moles and atoms. So how many moles and how many atoms of silicon are in a sample weighing 21? Now see how they have, okay? Mass of sample is given, atomic weight of silicon is known. So molar mass 28 is numerically equal to atomic weight. And then they have explained very nicely, okay?
Okay.
So you just go through this and see how they have calculated this mole. And we also know how to calculate go from mole to the number we multiplied by Na, right?
Okay. And what is this SI they've given?
Silicon.
Okay.
Okay. It does not matter what it is, huh?
All right.
From mole to number, huh?
Mm.
Okay. 3 century can be 3 century runs, 3 century years, huh?
Yes, sir. Yes, sir.
Got it? So you just go through and see everything, how many moles. So you have to go through these chapters, okay? And I just want to show you more things that see this is how this is also they have given you one very nice trick where we'll learn how to balance the equation, okay? So whenever we balance the equation, okay,
Yes, sir.
so they have explained a very nice method, very cool method how to balance. You just go and learn from here, okay? You know how to balance a bit,
Yes, sir.
okay? So here they have given a very nice trick, okay? Where is the trick? Where is the trick? I'm just looking for it. I just want to see.
Yes, sir.
Anyways, so we start with those atoms initially to balance, which appear only once in reactant and product. We start with those atoms, okay?
Yes, sir.
Okay, and that makes it easy. Anyways, so and if you'll see that they have given this balancing, how to balance chemical equation and everything, and see here they have given you also how to calculate, how we will calculate the molar masses. For example, C2H4, of 2 carbon, and they have added and everything, okay?
Okay.
Okay. Okay.
Yes, sir.
So you just go through and yeah, you'll find it.
Yeah, I'll
And
for now go through the first two chapters as much as I can, right?
yeah. And you can ask, huh? Okay.
Yeah.
Okay. I'll just shift this also to, if I can. Okay, I'll just leave it here on we are on the chapter 2. Okay. So because since you must be knowing a bit, so we can start like this. But I strongly advise you to go through everything, huh? Okay.
Yeah.
Yeah, that is because that is really important. Huh? So for example, now we'll continue with whatever we were doing. So whenever we have a balanced equation, what we can do is we can simply uh, write that mole AY. For example, now we are going to take another example. So I have, let us say, yeah, I'll take this C3H8. I'll just plus 5O2 goes to 3CO2 plus 4H2O. So from here, what I can write, Ritika, I can write mole C3H8 mole O2. Keep saying mole CO2 by mole H2O by. Okay, this is clear, huh?
Okay, yeah. Yeah, it's clear.
So again, we have managed to write, and again, I can see that if I know the mole of C3H8, then I can calculate the mole of O2. I can also calculate the mole of CO2, and I can also calculate the mole of H2O. Okay.
Okay, and when they ask questions, will they give one of the mole?
No. Sorry. What?
Like when they ask a question, let's say they ask us to find the mole of CO2, but they give us the mole of, will they give us the mole of C3H8?
Yeah. They have to give one mole. Huh?
They'll give one, okay.
Yeah. And don't even think what will happen. We are going through it. Okay. Just focus on this.
Okay.
Huh? Okay. You are too much worried. Huh? Okay. Don't be. Okay. Worrying has never helped anyone. Okay.
Okay.
See, if worrying would have helped, then everybody would have become the topper of IIT. Yeah?
Yes.
So worrying will never help. Only those people will do who are not worrying. So just focus on the process. You will know everything. Huh? Just don't. So I just want to get that conversion between the moles and masses. So I'll just put few small questions. For example, I asked that mass of 2 mole H2O. Okay. So see how we will do. So I have the formula that mole equal to given mass by molar mass, right?
Yeah.
And given mass in grams and molar mass is gram per mole, right?
Yeah.
So moles are given. Given mass is something which we have to ask because we don't know what will be the given mass for this, right?
Yeah.
How much will be the mass of this?
Yes,
And
sir.
so molar mass for H2O will be 18, right?
Yeah.
So 18 gram per mole.
Okay.
And right, and on the this side is 2 mole, right?
Yes, sir. So, okay.
So it means 2 mole multiplied by 18 gram per mole, right?
Yeah.
So it will be 36 grams, huh?
Yeah.
So 2 mole H2O will weigh 36 grams, right?
Okay. Yeah.
Clear?
Yes, sir. Yes, sir. Clear.
Okay, now we'll continue. See, mass of 3 mole CO2.
Okay.
So 3 mole and I multiply it by the molar mass of CO2. Okay. So for CO2, carbon is 12 plus 2 into 16. Okay.
Yeah.
So 44 gram per mole. Okay.
Yes, sir.
So this I multiply by 44 gram per.
Yeah.
So 3 mole of carbon will weigh 132 grams. Got it?
Yeah, got it.
So from mole, I can go to mass, right?
Yeah.
Okay. And from mass, I can go to mole. Huh?
Yeah.
Okay. Nice. So I'll just continue. See now, I'll question. how many gram of Na2CO3, H2O, and CO2 are produced on heating 16.8 gram NaHCO3. Okay, this is the question. I'll do it. Okay.
First we make equation then. Okay.
Yes, first is right. Without the balanced equation, we cannot do anything, right?
Yeah.
So the balanced equation is this.
Yes, sir.
And once I have this, I can write mole NaHCO3 divided by 2 is
Yeah.
equal to by 1, right?
Okay. Okay. So they're given the grams, so we'll find the mole. Okay.
Yes, yes. See. Now you are able to see what even I have not taught you, right?
Yeah.
So
Yeah.
that is what we are going to do, what you just said. So I've set up this now 16.8 grams. So from here, I can calculate mole NaHCO3, how much, which is given mass, which is 16.8 grams divided by molar mass. If you do, it will come out to be 84. Okay.
Okay.
Gram per mole. So this will be 0.2 mole. Okay. Okay.
Now, okay.
So I put this value here 0.2 by 2. So I can calculate the moles for every species.
Yes, sir.
So once I know the moles for all the species, so all moles are actually 0.1, right?
Yeah, all moles are 0.1.
So mole Na2CO3 is equal to 0.1. It implies, how do we calculate the mass of Na2CO3? Oh yes, that is very easy. I take its moles and multiply it by molar mass of Na2CO3, which is 106 gram per molar.
Okay.
Got it?
Yeah.
Mole H2O is also 0.1 mole.
Yeah.
So how do I calculate the mass of H2O? I take its moles and I multiply it by molar mass for this. Huh?
Yeah.
How do I so I mole for CO2 is also 0.1. And how do I calculate mass of CO2? I take its mole and multiply it by 44 gram per mole. So Ritika, whenever we are asked the masses, we will always find their moles first. Got it?
Okay.
Got it?
Yeah.
Clear, right? So we'll stop here, go through this, okay? And go through chapter 1 and 2, okay?
Okay.
Chapter 1 is very simple, and chapter 2, chapter 3, whatever you can go through, start with chapter 1, chapter 2. I'll suggest this. Yeah, you go through a bit of chapter 1 also, and then mainly start from chapter 2. Huh?
Okay. I'm just telling, right? For my exam, it's chapter 1 and then till Rutherford's experiment in chapter 2. And
don't worry, yeah. Okay.
Yeah. And
yeah.
I just wanted to tell you, right? So like my
no, don't tell me, yeah. Because we will not, in any way, we will not study according to your exam.
Okay, but like my main focus is CBSE, so
Yeah, I know your main. See, Ritika, you cannot. You are just a child. Huh? I'm teaching children like you for 24 years. Okay, so your main focus should always be learning the concepts. Okay.
Yeah.
So once you have learned it, you will be able to handle CBSE. Okay.
Okay.
Okay. We do not focus on the results. Huh? We focus on the process. Okay.
All right.
You are getting me? What I'm saying?
Yeah.
This is what Krishna advised to Arjuna. Don't focus on the results, just focus on the karma. Karma is the process, okay?
Yeah. Yes,
okay, okay. So everywhere, Dhoni also says this, focus on the process, because results and everything, they are not on your hand, in your hands.
Yes, sir.
So we are always focusing on the process, and everything will come out right, obviously, because if the process will be good, obviously the results will be good, okay?
Yes, sir.
Okay. So what Krishna is trying to say is that if you just focus on the results, you will always be anxious. Okay. He's not saying that your results should not be good. Okay. But he's saying that if you just focus on the process, you will never be anxious, and the results will also be good. Okay.
Yes, sir.
Got it?
Yeah.
Okay, chalo. Take care. I'll upload this on the YouTube with your name. Huh? I'll make a playlist. Okay. And I'll share everything. Okay. Okay.
Okay.
And I'll share this notebook also with you. Okay. Revise
Okay,
everything. Huh? Okay. We'll meet tomorrow. Huh?
yeah, okay. Thank you,
Okay.
sir.
Chalo.
Bye, sir.
Bye. Bye. Bye.